finding the greatest common factor and the least common multiple of numbers with the third method, which is using factor trees. The reason for this is the latter method works great for pairs of numbers, but when you have three numbers, the factor tree method is the way to go because the latter method doesn't work all the time. So just a quick review of the other two methods. If you had to find the greatest common factor of 16 and 24, we've learned two methods so far. One making lists and one using the ladder method. So if you look at my list here, I have all the factors of 16 and all the factors of 24 in order. If you make a list of all the factors of two numbers, then you can compare the lists and find the factor that is the biggest. We call that the greatest common factor. So looking at this list, 24 is not in both lists. 16 is not in both lists. 12 is not in both lists. But 8 is in both lists. Therefore, we say the greatest common factor of 16 and 24 is 8 using the list method, or GCF is equal to 8. The latter method over here is really nice because it's quicker. So if you look at the two numbers 16 and 24 and think of any common factor they have, like 4 for example, you can take that out and do division. 16 divided by 4 is 4, and then 24 divided by 4 is 6, and you just repeat the process until the bottom of the ladder, the numbers at the bottom only have the common factor of 1. Once that's done, these numbers on the side, their product forms the GCF. We get 8 either way. So today's goal is to teach you how to use prime factorization to do this. And even though it's a little more difficult of a method, it works for 3 numbers all the time. But first, just to show you the method, I'm going to do the exact same problem with 16 and 24 by creating a factor tree. So 4 times 4 is 16. Neither one of those is prime, so I continue the branches. 2 times 2 is 4. So I circle my prime numbers. Repeat that over here because I have the same number. So my prime factorization of 16 is 2 times 2 times 2 times 2. Now I'm going to do the prime factorization of 24. So I pick any 2 numbers that multiply to give me 24, such as 8 and 3. Since 3 is prime, I circle it. Since 8 is not, I put another set of branches. 4 times 2 is 8. Since 2 is prime, I circle it. Since 4 is not, I put another set of branches. Now I have primes. So my prime factorization in 24 is 2 times 2 times 2 times 3. To get the greatest common factor of 16 and 24 with factor trees, you take the prime factorization of each number, and I like to line them up, line up the things that are common, and separate the things that are not. So every time you have a common pair, circle the group until you run out of common pairs. So as you see, there's 3 common sets of 2. But this doesn't have a pair, and that doesn't have a pair, so they are not common factors. So to find the greatest common factor, you take those three sets, and you take one number representing each set, and multiply them together. 2 times 2 is 4. 4 times 2 is 8. So again, for the same two numbers, 16 and 24, we get the greatest common factor is still 8 using the factor tree method. Now, my guess is most people like this method, the ladder. The problem is, when you have three numbers, the ladder doesn't work. So we're going to practice with three numbers. Now we're going to do the same process. We're going to find the greatest common factor with three numbers, but you have to use the factor tree method. So I already know what the prime factorization of 16 is, because I have it on this page here. So I'm going to just copy that work. 2 times 2 times 2 times 2. But I need to find the prime factorization of 14. That's an easy factor tree. It's just 2 times 7, because both of those numbers are prime. So the prime factorization of 14, I'm going to write under 16. And another way to do it is line up common. So 2, but since 7 is not common, I just move it to the side. Now I need to do the prime factorization of 12. I haven't done that one yet. So that's 2 times 6. Since 2 is common, prime, I circle it. 6 is not. So I do 2 times 3. Now both of those are prime. So the prime factorization of 12 is 2. Since I have a common 2, I line it up. Times 2, but there's no 3. I just put it over here. Now, when I look for the greatest common factor of 12, 14, and 16, the only thing that shows up in all three numbers is 2. So the greatest common factor is just 2. The next thing we're going to do is use the factor tree method to find the least common multiple. To find the least common multiple of two numbers, just like we did with the greatest common factor, we can look back at our review methods. One way to find the least common multiple is to list the multiples of your numbers in order from low to high and find the first one that's common to both. So this top row has the multiples of 16, and the second row has the multiples of 24. And the least common multiple, the first one that's common to both, is 48. So we say the LCM is 48. Or you could go to the division ladder, which we started a few minutes ago for the GCF. That's where we found the GCF to be 8. But we can use the division ladder by taking the bottom of the division ladder and multiplying it by the top of the opposite side to get the LCM. LCM is equal to 2 times 24, which is equal to 48. And if you remember, I could have chosen the bottom of the right side, and I would have multiplied by the top of the left side, because 3 times 16 is also 48. So now we're going to use factor trees to do the same thing. So actually, let's do the factor trees of 16 and 24. So if I do a factor tree for 16 and a factor tree for 24, we repeat this process where 16 is 8 times 2, 8 is 4 times 2, 4 is 2 times 2, and we circle all the primes. And for 24, you might remember the factor tree for 24 is 8 times 3, 8 is 4 times 2, 4 is 2 times 2, we circle all the primes. Now, just like we did with the GCFs, we line the factors up. 16 is 2 times 2 times 2 times 2. 24, the prime factorization is 2 times 2 times 2, and then I move the 3 over because it's not common. To get the LCM, you begin like you're doing the GCF. You circle all the common ones. And take those numbers, 2 times 2 times 2. And then you take the numbers that weren't circled and bring them in. That should be a 3. And make that factor string, multiply it out, and you should get the least common multiple. So 2 times 2 times 2 is 8. Times 2 more is 16. Times 3 is 48. So if we use factor trees to get the same answer for the least common multiple. Again, it's a little more work. Some people actually prefer it. But with 3 numbers, it works nicely. So let's go back to finding the least common multiple of 12, 14, and 16. And we're going to start with our work from the greatest common factor. We already figured out that the greatest common factor was 2, move that up here, using the factor trees. And to get the LCM, you take the common number, which is 2, and then you multiply by all of the other numbers that are left over. So to make this easy to follow, you can get rid of these factor trees and work right below my problem. I think it'll be easier to follow. So I take this 2, and then I take a representative from each other row. This 2, that 2, that 2, that 7, and that 3. And I'm going to multiply all of these together. So 2 times 2 times 2 times 2 is 16. You can times that by 7 and then multiply the whole answer by 3. Just to save a little bit of time, bring up the calculator here. It disappeared. I'll just multiply it out. 16 times 7. 7 times 6 is 42. Carry the 4. 7 times 1 is 7 plus 4 is 11. So 112. Now we're going to take that 112 and multiply it by 3. So 3 times 100 is 300. 3 times 12 is 36. So the least common multiple of 12 14 and 16 is 336.